This is Venkatramana, Mathematics Department, Vardhaman College of Engineering, Assistant Professor. In this lecture, we are going to know about the gamma function. So, gamma function we are using to evaluate the definite integral values which are in the form of e power minus x into x power n minus 1 dx, and these integrals are very difficult to evaluate the solutions. So in that's why we are knowing about the definition of gamma function. By using gamma function easily we are evaluating the solutions of the definite integrals. Now definition of the gamma function. Gamma function we are defining for every positive value of n. If n greater than 0, then the definite integral 0 to infinity e power minus x into x power n minus 1 dx. This one is known as gamma function. Generally it is denoted by gamma of n and read as gamma of n. This is wording, and so gamma of n formula is integral 0 to infinity e power minus x power n minus 1 dx. So by using this gamma definition we are evaluating the standard results. Gamma of 1 is equal to 1, gamma of n plus 1 is equal n into gamma of n. This is called reduction formula of gamma of n. If we are replacing n as n minus 1 in this one, then this one changes as gamma of n is equal n minus 1 into gamma of n minus 1. Third one, gamma of n is equal, it is n minus 1 factorial. If you are doing repeating this formula continuously, you will get gamma of n is equal n minus 1 factorial. Now we are doing some of the problems which are related with the formulas. First one, gamma of 9. Here n is an integer. Already we know one of the property of the gamma function is gamma of n is equal n minus 1 factorial. N minus 1 factorial. By using this formula we are calculating the value of this one. Gamma of 9 is equal 9 minus 1 factorial is equal 8 factorial. This formula we are using for n is integer. N is positive integer. Now coming to the second problem. Second one is gamma of 5 by 2. If you are observing here, n is a rational number. For the rational number, we are using the formula gamma of n is equal n minus 1 into gamma of n minus 1, which is called reduction formula. By observing this, here n value is 5 by 2. Substitute n as 5 by 2. Then this one 5 by 2 minus 1 into gamma of 5 by 2 minus 1. 5 by 2 minus 1 value is 3 by 2. Gamma of 5 by 2 minus 1 is gamma of 3 by 2. Again we have gamma of 3 by 2. Again same formula apply this one. 3 by 2 into gamma of 3 by 2. Again same 3 by 2 minus 1 into gamma of 3 by 2 minus 1. This one is equal 3 by 2 into 1 by 2 gamma of 1 by 2. Now we are stopping this gamma expansion. Because of that, in this rational number, numerator is smaller than denominator. So this formula we are applying up to the numerator becomes as smaller than the denominator, and this is equal 3 by 4 into gamma of 1 by 2. Gamma of 1 by 2 value is root pi. Gamma of 1 by 2 is root pi. In the next lecture, we are discussing about the gamma of 1 by 2 is equal root pi. Now we are doing one more problem on this gamma function. Gamma of minus 3 by 2. Here n is negative rational number. We have formula gamma of n plus 1 is equal n into gamma of n, reduction formula. From this, gamma of n is equal gamma of n plus 1 by n. This formula we are using for n negative rational number. Now n value as minus 3 by 2. Substitute here. Gamma of minus 3 by 2 is equal gamma of minus 3 by 2 plus 1 by minus 3 by 2 plus 1. Gamma of minus 3 by 2 plus 1 value is gamma of minus 1 by 2 by minus 1 by 2. Minus 1 by 2 changes as minus 2. This formula we are using till this one changes as gamma, inside gamma value changes as a positive value. Gamma of minus 1 by 2, same formula apply, n as minus 1 by 2, then this one minus 1 by 2 plus 1 by minus 1 by 2 plus 1. This one is equal minus 2 into minus 1 by 2 plus 1, 1 by 2. Changes as 2. Gamma of minus 1 by 2 plus 1, gamma of 1 by 2. We know the value of gamma of 1 by 2 is root pi. So this one is minus 4 root pi. So here we used three formulas. One is gamma of n is equal to n minus 1 factorial. This one we are using if n is positive integer. And second formula, gamma of n is equal to n minus 1 into gamma of n minus 1. This formula we are using if n is positive rational number. Positive rational number. Whereas coming to here, this formula we are using for n is negative rational number. So everyone keep. For this we are using the definition of gamma. We are using the substitution for this. T is equal to x square, so dt is equal to x dx. Change the limits also. T tends to 0 implies x tends to 0. T tends to infinity implies x tends to infinity. Let it be equation number 1. Substitute these are all in the equation number 1. Gamma of n is equal integral 0 to infinity e power minus x square power n minus 1 dt value 2x dx. 2 into integral 0 to infinity e power minus x square x power 2n minus 2 here power 1 plus 1 dx. 2 into integral 0 to infinity e power minus x square x power 2n minus 1 dx. Left hand side is gamma of n. Now in this one substitute n as 1 by 2. Gamma of 1 by 2 is equal to into integral 0 to infinity e power minus x square. 2 getting cancelled. 2 into 1 by 2 minus 1 dx. This one gamma of 1 by 2 is equal 2 into integral 0 to infinity e power minus x square dx. Let it be equation number 2. Here change the variable x as y. We will get one more gamma. Gamma of 1 by 2 is equal 2 into integral 0 to infinity e power minus y square dy. Let it be equation number 3. Multiply 2 and 3. Left hand side gamma of 1 by 2 into gamma of 1 by 2. Right hand side 2 into integral 0 to infinity e power minus x square dx. 2 into integral 0 to infinity e power minus y square dy. Left hand side is gamma of 1 by 2 into gamma of 1 by 2, gamma of 1 by 2 whole square. Right hand side 2 into 2 4, 0 to infinity, 0 to infinity, e power bases are equal, e power minus x square into minus y square dx dy. Gamma of 1 by 2 whole square is equal 4 into 0 to infinity, 0 to infinity, bases are equal, power should be added and take common minus. So gamma of 1 by 2 whole square is equal 4 into integral 0 to infinity, 0 to infinity e power minus x square plus y square dx dy. Let it be equation number 4. And here it is double integral. Now we are converting this double integral into polar coordinates. So by changing into polar coordinates, use the substitution. X is equal to r cos theta, y is equal to r sin theta, and dx dy is equal small r dr d theta. This is conversion into polar coordinates. That means this integral converts into r comma theta. Now we want to evaluate the limits of r comma theta. For this, first we need to trace this region, x changing from 0 to infinity, y changing from 0 to infinity. Trace that region. For that, draw this x axis, y axis. And here the x limits are 0 to infinity. Draw 0 to infinity. X means starting here, x axis, x 0 to infinity. This total region is 0 to infinity region. Whereas coming to the y limits, y changing from 0 to infinity. Y is this one, 0 to infinity, 0 to infinity. This total region is 0 to infinity. If you are observing this x and y, the common region is first quadrant. So this is our first quadrant, this is our common region. In this region we need to calculate the limits of theta and r. Here we know that theta always 0 on x-axis. Here it is pi by 2. Whereas coming to r, radius always starting with 0, it is going up to infinity. So in this region, theta varies from 0 to pi by 2, radius varies from 0 to infinity. Now substitute these are all in equation number 4. 4 implies left hand side gamma of 1 by 2 whole square, right hand side 4 into theta limits 0 to pi by 2, r limits 0 to infinity, e power minus x square value r square cos square theta, y square value r square sin square theta, dx dy is small r dr d theta. Now this one is equal 4 into integral 0 to infinity, 0 to infinity, take out common minus r square, remaining is cos square theta plus sin square theta dr d theta, and here limits are 0 to pi by 2, 0 to infinity. 4 into 0 to pi by 2, 0 to infinity, e power minus r square dr d theta. Now we are evaluating the integral of this one. Left hand side is what? Gamma of 1 by 2 whole square. Here for our convenient purpose I am writing 4 as minus 2, 0 to pi by 2, 0 to infinity, e power minus r square minus here small r existing, small r dr d theta. See here it is small r, small r, small r, continuation. Minus 2 into first integration with respect to r. Here you need to know the one of the formula. That one is integral e power f of x into f dash of x dx is equal e power f of x. This is our formula. Here r square minus r square is f of x, minus 2r is f dash of x. So use this formula here, then this one changes as 0 to pi by 2, and here this one is e power minus r square, limits are 0 to infinity d theta. This one is equal minus 2 into substitute upper limit and lower limits in this one, it is 0 minus 1 d theta. 2 into integral 0 to pi by 2, 1 d theta. Integration of 1 is theta, limits are 0 to pi by 2. So 2 into upper limit minus lower limit, value is pi, left hand side is gamma of 1 by 2 whole square. From this Apply square root on both sides. We are getting gamma of 1 by 2 is equal root pi. Thank you.